Okay, here's an example where you can use your table mode to your advantage. This is a compound interest question. Tony invests $80,500 for N years at 7.8% per annum per year, compounding annually. The interest rate is fixed for the duration of the investment. The value of the investment after N years is given by V equals 8500 times 1.078 to the power N dollars. Now, there's absolutely no obligation on the examiner to give you this formula. You, having studied compound interest, should know that that is the future value formula. So future value equals present value, as in the initial investment, times the multiplier, so the number you multiply by to increase a number by 7.8% to the power of the number of years. So hopefully you all remember that. And the question is, how long will it take for Tony's investment to amount to $12,000? How long will it take for his investment to double in value? So double in value, well, it starts off at 8500. So double that, well, it's double 8,000 plus double 500, 16,000 plus 1,000. So once there is more than $17,000 in the account, then you know that Tony's doubled his investment, right? So table mode is really, really handy for this because repeated calculations, it enables you to avoid doing repeated boring calculations. Because all you're really doing is substituting integer values into a formula. So to get table mode, menu table, so menu 7. If you've got a formula that you don't want, get rid of it. And then you need to type in, so 8500 times 1.078. The power is this button here to the power of x. So there's your table. Now you do need to think about your setup. So we're talking about how many years. So the first year is year 1. So I definitely want to know how much money is in the bank account after year 1. It's very unlikely in this question that the answer is going to be less than 4 years. So we definitely want to be more than 4. So they're around 10 years, 11 years, 12 years. So I reckon if we go up to 15 years, that will probably cover it. If you find out 15 years isn't enough, you can always just come back and change the settings again. It's really not that hard. But I'm going to go with 15. So table set up, execute. And then there is your table. And it's as simple as that. All of these y values are the future value after n years. So after 1 year, there's that much in the account. If after 2 years, there's this much, and so on. It's really quite simple. So we're looking for 12,000. When is there $12,000 in the account? So you just go down. You're looking for 12,000 or more. So you can see after 5 years, there is 12374. So $12,374 in the account, whereas after 4 years, there was only 11,478. The answer will not be 4 point something. It's being compounded annually, so these interest payments only happen each year. The answer is definitely 5, but you should show a little bit of working. I would say the minimum working that guarantees you full marks would be something like this. So show let me get the calculator back. Show that after 4 years there's that much in the account. Show that after 5 years there's this much in the account, which goes past your key value of 12,000, and then mark the answer 5 years. Right, so for part B, how long will it take for his investment to double? Well, it doubles when there's 17,000 or more in the account. So you just keep going down the tables. And you can see after 9 years, there's a bit less than 17,000, 16710. After 10 years, there's actually 18,000, so much more than 17,000. So the answer is 10. And again, a little bit of working, maybe slightly more. You might show the examiner that you know what doubling means. So this word double means times by 2. So 8,000 times 2 is 17,000. Show that there's less than 17,000 after 9 years. Show the substitution, show the number. Show that there's more after 10 years. Mark the answer 10 years. And that is all you need to do.